Have you ever wondered why the zeros of a polynomial are so important? An understanding of the geometrical representations of polynomials and the geometrical meaning of their zeros will answer this question. Let's start with the definition of zero of a polynomial. A zero of a polynomial is that value of x at which the polynomial p of x is equal to 0. If p of x is a polynomial and a is a real number such that p of a is equal to 0, then the following statements are equivalent. A is a zero of p of x. A is a solution of the polynomial equation p of x is equal to 0. And x minus a is a factor of the polynomial p of x. The x-intercept is that value of x where the graph touches or crosses the x-axis. At the x-intercept, y is equal to p of x is equal to 0. A polynomial function of degree n has at most n zeros. Let's look at the graph of a constant function. F of x is equal to 3 is a constant function with degree is equal to 0. What do you think the graph is like? The graph is a straight line that does not intersect the x-axis at any point. Hence, it has 0 x-intercepts. Now, what do you think the graph will be like for a linear polynomial of degree 1? Suppose f of x is equal to x plus 2. Look at the graph. You can see that it intersects the x-axis at only one point, minus 2, 0. Hence, its x-intercept at that point is minus 2. In other words, at the point minus 2, 0, y is equal to f of x is equal to 0. Thus, the number of zeros is 1 for a linear polynomial of degree 1. What is the geometric meaning of 0 for a linear polynomial? The graph of the linear polynomial f of x is equal to ax plus b, where a is not equal to 0, is a straight line. It intersects the x-axis at exactly one point minus b by a, 0. Therefore, the linear polynomial has only one zero, which is the x-coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. What do you think are the zeros of the following quadratic polynomials? P of x is equal to x squared plus 2x minus 15. When we solve p of x is equal to x squared plus 2x minus 15, we get x plus 5 multiplied by x minus 3. This implies that p of x is equal to 0 when x is equal to minus 5 and x is equal to 3. Let us see the graph of p of x is equal to x squared plus 2x minus 15. What are the x-intercepts of the graph? You can see that y is equal to 0 at 2 points, minus 5, 0 and 3, 0. Therefore, the x-intercepts are minus 5, 0 and 3, 0. Let us see another graph of a quadratic polynomial. F of x is equal to x squared plus 3x plus 2 is a quadratic polynomial of degree 2. F of x is equal to x plus 1 multiplied by x plus 2. This implies that f of x is equal to 0 when x is equal to -1 and x is equal to -2. Let us see the graph of the polynomial. It meets the x-axis at 2 points, -2, 0 and -1, 0. Hence, the x-intercepts are -2 and -1. Thus, the maximum number of zeros for a quadratic polynomial of degree 2 is 2. Therefore, we can conclude that the x-intercepts in the graph are the zeros of the polynomial. Now, let's look at a cubic polynomial. f of x is equal to y is equal to x cubed minus 4x. This is a polynomial of degree 3. So, what will the graph be like and what are the maximum zeros possible? Let's take a look at the graph. There are 3 x-intercepts. Therefore, the maximum zeros for a cubic polynomial of degree 3 is 3. Can you find all the zeros and turning points of the graph of f of x is equal to x to the power 4 minus x cubed minus 2x square? When we factor the polynomial, we get f of x is equal to x to the power of 4 minus x cubed minus 2x square. This is equal to x square multiplied by x plus 1 multiplied by x minus 2. The zeros of this polynomial are x is equal to -1, x is equal to 0, and x is equal to 2. These correspond to the x-intercepts -1, 0, 0, 0, and 2, 0. The graph shows that there are 3 turning points. Since the degree is 4, this is the maximum number possible. A polynomial function graph consists of a series of hills and valleys called turning points. The maximum number of turning points is 1 less than the degree of the polynomial. For example, if the degree of the polynomial is 3, the graph would have a maximum of 2 turning points. In a polynomial function, 0 is an x value for which y is equal to 0. It is the value at which the graph touches or cuts the x-axis. In a polynomial, the maximum number of zeros is equal to its degree. The quadratic polynomial f of x is equal to ax square plus bx plus c can have 3 cases for the graphs. Case 1. There are 2 zeros where the graph cuts x-axis at 2 distinct points. Case 2. There is 1 zero where the graph cuts x-axis at exactly 1 point. Case 3. There are no zeros when the graph does not cut x-axis at all. Select the correct option and click Submit. Select the correct option and click Submit. Select the correct option and click Submit.